The brain creates who we are. It's constantly processing masses of information so we can make sense of the world around us. It plans and guides every move we make, and it's the seat of our emotions and personality. I'm meeting up with neuroscientist Dr. Bo Lotto, who's investigating how our brains have evolved to make sense of the world. We call it perception, but how exactly does it work? Optical illusions provide us with fascinating clues about how our brains process the flood of images entering our eyes. So this one, whether he's Tweedledum or Tweedledee, I'm not sure, but he looks to me like he's pretty rounded, fleshed out.
Like it's coming out at you.
Yeah. In fact, clever lighting is fooling the brain into thinking that both figures are protruding. The left-hand figure is actually concave.
What the brain has to do, it has to construct what it sees from its experience. And the only way it can do that is by shaping itself according to the sort of the trial and error process of interacting with the world.
So in reality, everything we see is an illusion. But the brain's ability to interpret all the information it's bombarded with is crucial for our survival. The brain is an exceptional organ, but like all the others, it needs looking after. And diet and lifestyle have a big impact on it, just as on any organ. But what makes for a brain-friendly lifestyle? 27-year-old Sean Gilbertson is keen to boost his brain power. Sean is a busy teacher at Llaniltyd Primary School in South Wales.
It is the best job in the world. I wouldn't stop for anything, to be honest. You can influence young people's lives. What I do today could shape a young person's life for the rest of their life.
Sean is using his brain all day long, but he's worried that his memory is letting him down.
Right. Megan? Kayla?
He thinks his memory problems are a direct result of his other great passion, sport. As well as being PE coordinator for the school, he regularly plays for his local rugby team. I've come to meet Sean. It's actually quite difficult because he doesn't have much free time, because all the time he's not teaching is pretty much taken up with this, and I think rugby is actually his first love. His passion for rugby means that physically he's super fit. But there are some downsides to it as well, aren't there?
Yeah, one or two. I'm quite susceptible to get knocked out quite often. So, yeah, I get quite a lot of concussions.
So how often does it happen?
I would say about 3-4 times a year, which is roughly then.
Really?
Yeah, so about 20-odd, 30-odd in the last about 10 years. First time I got knocked out was when I was 17. It's the first time I ever got knocked out. And ever since then, I've been getting concussions quite regularly, to be honest.
Well, have a look at the brain in a bit more detail, and in particular memory, because you're worried about your memory, aren't you?
Yeah, it's not the best. It's lucky actually made it here tonight, to be honest. I actually remember it. But my memory's not very. My short-term memory's terrible. Like my kids in my class in school, they're constantly leaving little notes to me or messages on the board that you got to meet my mum tonight.
Oh, you remind me. You know, you've got to remind me then.
I'm constantly saying, boss. I meant Thomas.
Why do plants have flowers? Michaela. Bit of pollen won't hurt you, Carly.
I have to say this is something I can totally relate to, because I'm fine with faces, but I'm really not good with names at all.
Try having 27 children in your class.
I've got 240 medical students.
Okay, you win. Okay.
Before we see if we can do anything to improve Sean's memory, let's take a closer look at the body's most sophisticated organ. I'm just sort of sketching the boundaries of the brain at the moment before I start filling in some of the details. We humans have big brains. Most of it is made up of the cortex, which forms the outer rind. It's folded in on itself to pack in more nerve cells. I suppose it's like writing something on a very big sheet of paper and then crumpling it up. You've still got the information there, but you've crumpled it into a smaller size. Right. The brain is divided into 4 lobes on each side, and each of them has a different function. So this is almost done now, so we've almost got Trevor's brain in all its splendour. And you can see the different lobes. This lobe here is the frontal lobe of the brain. And that's really where your personality is, where your emotions are, that sort of thing. The parietal lobe on the side of the head here, that's where the brain receives the sensations from your body. Right at the back of the head here, the occipital lobe is to do with vision, so this is receiving signals from the eyes. And this lobe here is the temporal lobe, which is to do with hearing and smell, and deep within it, memory as well.
I've invited Sean along to the lab to find out a bit more about the contents of his skull.
So Sean, this is a horse's brain. It's quite a bit smaller than a human brain, but it's got all the same bits that a human brain has got. It's just that it hasn't got as much cerebral cortex, so horses aren't quite as clever as us. Do you want to pick that up and have a feel of it? It's a very odd texture.
Oh.
It's quite floppy, isn't it?
Yes, it's like a bag of mints.
Very, very strange indeed. It's almost like a sort of blancmange texture when it's fresh like this. If you look at the top of the brain, really all you see is the cortex. And if you turn it over, you start to see a few more things. That's actually part of the optic nerve just there that comes from the back of the eye.
Right.
So that's bringing all the information from the eyes back to the brain.
Slicing through the brain reveals two distinct layers, the outer grey matter and the inner white matter.
So what is the actual difference between the grey matter and the white matter?
It's different parts of nerve cells, essentially. So on the outside, we've got the little bodies of the nerve cells with their nuclei in, and they're all sitting in the cortex. And then in the white matter, what you've got are the little processes which form the sort of wiring of the brain, as it were. What you're looking at there is billions and billions of neurons and billions of connections between them.
At the back of the brain is a tree-shaped structure, the cerebellum.
So what does the cerebellum actually do?
It's really important in controlling your posture and balance, and it also coordinates all your muscles as well. It's obviously going to be important to you when you're sort of running on the field and tackling and all of that sort of thing.
So we've had a good look at a horse's brain, but I want to take a closer look at a living one, my own. I'm about to have a magnetic resonance image, or MRI, scan. Within just 10 minutes, it's produced images of nearly 200 slices through my brain.
This is just amazing, because what I'm looking at here are pictures of my own brain. And you can see all these amazing structures on it, so you can actually see the hippocampus, where a lot of memory goes on. You can see the cerebellum really beautifully, this little tree-like structure at the base of the brain. And it is just very weird to think that somewhere in here in the frontal lobe is where my personality resides, all my emotions are going on in here. It's also, I have to say, extremely reassuring that it looks nicely symmetrical. Wonderful bit of living anatomy.
It's strange to think that this physical object holds our minds and contains all our memories.
I'm going to give you 15 seconds to look at these items. I want you to remember them in order.
I shan't remember.
OK, I'll cover it back over, and then I want you to relay it back to me. Here we go. Let's see how we did.
Teeth, dinosaur.
A thermometer, glasses.
Temperature thingy, glasses.
Do you remember the order of them?
No.
Screwdriver.
Yes.
Tomato.
I've lost the order because I did it all out of order first.
I think tomato or something like that.
And I really think that's it.
You got 6. Look, the next one was
Apple.
And that's all I remember now.
Most people can only remember 7 or 8 objects in a sequence. Dominic O'Brien can remember 54 decks of shuffle cards after seeing them just once. He's won the World Memory Championship 8 times. Sean and I have met up with him to see if he's got any tips for how Sean can improve his memory. But first we test him out on a pack of shuffled cards.
Right then, so what do you want me to do? Just...
I'll go through the deck and you can check them as I go through.
OK.
So I'll close my eyes.
Right.
Right, so it starts with the 7 of diamonds, then the Jack of hearts, then the 9 of clubs, 2 of clubs, is that right?
Yeah.
5 of hearts, 10 of clubs, 7 of clubs, 6 of spades, 3 of diamonds, 9 of hearts, the 4 of clubs, ace of spades, and then the 8 of diamonds, then the 2 of spades, and then the 10 of diamonds and 4 of diamonds.
Wow.
Well, I'm impressed. Do you want to have a go, Sean?
2 diamonds, that's all I can remember.
But what exactly is memory? Brain activity consists of electrical signals passing along neurons, and the billions of neurons in the brain also talk to each other at their connections or synapses. Getting the same signal over again increases the strength of the response, and this is the basis of memory and learning. I want to find out if there's something special going on in Dominic's brain which accounts for his amazing memory. Sean, Dominic and I have come to Cardiff University Brain Scanner Unit. We're going to be comparing which areas of their brains are activated when they're given a simple memory test. While they're under the scanner, Dr. Ella Hinton will show them a series of descriptions. They then have to indicate whether various statements are true or false.
So Sean is in the MRI machine actually performing the memory task, and at the same time his brain is being scanned by the MRI machine incredibly quickly, collecting massive amounts of data that can then be analysed to show which parts of his brain are active as he's remembering.
With the scans finished, it's time for the results.
So, Ella, have you got the results of the test back?
Yep.
How did they do?
Well, I have to say they both did really well. So, Sean, you got 80% overall on the memory test.
Never.
Yeah.
Well guessed.
Okay. And Dominic, you did really well. You got 100%. So.
Oh, did I?
Wow.
Oh.
That's fantastic. So, how did you do it?
I was using a spatial strategy. So, for example, one of the questions was, Sonia is taller than Grace. So I imagine Sonia, somebody I know, opening a dormer window and looking down at Grace, who was opening the first floor window. So looking at each other like that. And then the next bit of information would come along, yes, but Wendy's taller than Sonia. So she'd have to be on the chimney talking to Sonia. So I'm building up the information. I'm using mnemonics as well.
And what about you, Sean? Were there any strategies that you were using to try and remember this information?
Well, basically, I was just trying to remember the information, but there was one section was all people I knew, so I could visualise them that way.
Yeah.
But that was only for a couple. The rest, I just try and remember as much as I could.
So we've got two very different sort of memory strategies going on there. Is that reflected at all in the scans?
Well, I think it might be, yes. Here, if we look at Dominic's activity, we can see in the left prefrontal cortex areas activated that are known to be associated with working memory and reasoning, so that fits with the task. But also, which is interesting from what you've just said about the strategy you were using, was this area here and is known for processing visual objects, so interpreting the visual world.
So when Dominic's thinking about these people in various parts of buildings, it's lighting up that bit of the brain,
It's lighting
probably.
up this bit of the brain.
Yeah.
When we look at Sean's scan, there's no activity in this part of the brain. The key to Dominic's exceptional memory seems to be his technique of turning what he needs to remember into an imaginary journey.
So, Dominic, do you think your technique, this sort of visualisation technique, could actually help Sean to, for instance, remember the names of all the school kids in his class?
Definitely. I mean, this is one of the things I have to do is memorise audiences when I'm doing after dinners. And there could be 100, 150 people there. I couldn't possibly do it unless I was using a journey method. So, yes, I'll teach you the journey method and so you can remember your students.
Hope we've got a couple of days to do that, because
it doesn't take that long.
Oh, right. You haven't met me, then.
So there are techniques we can use to improve our memories.
Your brain is in its 80s.
But how can we go about preventing memory loss?
Just as physical activity is good for your whole body, mental activity is good for your brain. It's the old use it or lose it principle. And there are loads of these brain trainers on the market at the moment, some of them brain teasers in books and some of them computer games. There's no hard evidence to show that any of these do boost your brain power,
But nonetheless, there is evidence to show that keeping mentally active protects against memory loss and reduces the risk of Alzheimer's. And that can be anything from stimulating conversation, keeping socially active, reading, that sort of thing. You don't need to spend money on all of these. And there are other ways we can make the best of our brains. Having a good night's sleep, for example. It's something that Sean's not getting at the moment.
The earliest I go to bed in the week is probably at 12 o'clock, 12:30, the very earliest. And I'm absolutely knackered the next day.
Just like Sean, I often find it difficult to get the recommended 7 to 8 hours of sleep a night. But now I'm going to find out what happens when I deliberately deprive myself of sleep. I'm off to see a colleague of mine at Bristol University, sleep expert Dr. Sharad Tahiri, who's going to be running the experiment.
Ready? What we're going to do is a very simple test.
To begin with, he gives me a simple cognitive test to see how I do on my normal sleep quota.
86 minus 7 is 79, 72, 65, 58.
Then it's off to the hotel where I'll be based while I cut down on my shut-eye. Over the next 48 hours, I'll be getting just 4 hours sleep a night. And I'm not looking forward to it. It reminds me of my nights on call.
Right, it's 2 o'clock, nearly, and I'm going to wake myself up at 6. I'm filling in my sleep diary, and I'm also wearing this watch-like device, which is actually going to measure my activity during the day and also at night while I'm asleep.
It's oh so quiet. Shh, shh.
Oh dear.
The following morning, the lack of sleep is already having an effect. I'm feeling quite tired, obviously, because I've only had 4 hours sleep. And I really, really want a coffee. And I'm not allowed to drink anything with caffeine in it, so I've got green tea. I have to redo everything I've done tonight because I'm too tired and I'm just making loads of mistakes. And I've been making mistakes all day as well. I've been doing stupid things like getting wrong keys out to open doors, and I've still got another night of only 4 hours sleep. Oh, God. It's the morning of day 2 and I'm feeling wretched. I can't wait for it all to be over.
Minus 7 is 30.
Back at Dr. Tahiri's, it's time to discover how I've fared.
12 seconds.
I'm fine with simple subtraction, but what happens with the harder sums?
Last time, the test took you about 11.5 minutes.
Yeah.
And what's so interesting this time is that the test took you 15.5 minutes.
Really?
Okay. So you were about 4 minutes slower than you were before.
I didn't feel as though it went any slower.
What was even more remarkable was that last time you only made 2 errors, and this time you made 6 errors.
Really?
In the test.
And when it comes to my appetite, there are more surprises in store.
When you were sleeping your usual hours, you were eating about 1,700, 1,800 calories. But when you were sleep deprived, and I'm quite amazed, because I didn't expect this to happen so quickly, is that your intake went up to 2,000 calories.
So just 2 nights sleep deprivation has not only affected my mental powers, it's also had an impact on my calorie intake. The results are in line with larger scale studies which show a link between persistent lack of sleep and obesity. So we found out about the effects of sleep on the brain, but also very interestingly on appetite as well. And as for me, I'm off home to get an early night. Resting the brain is important, and so is protecting it from injury. While Sean's love of rugby benefits his brain by keeping the blood vessels supplying it with oxygen healthy, the knocks to the head he's getting are not. Recent studies have suggested that playing a sport where you regularly suffer blows to the head could make you 3 times more likely to develop Alzheimer's. To protect it from injury, the soft, vulnerable brain is encased in a thick, hard skull, but the tight fit can also prove to be the brain's downfall.
This MRI scan shows just how snug a fit it is for the brain inside the skull. You can see the edge of the brain here, and then this is the skull just around the outside. So there's a little bit of room between the brain and the skull, but not much.
If anything else starts to take up room in the skull, like a tumour or a bleed, the increased pressure within the skull can have dire consequences. 79-year-old Peggy Crowley has been admitted to King's College Hospital in London after a stroke caused by a massive bleed in her brain. Surgeon Sanj Bassi must remove the clot as soon as possible.
She's had a CT scan today which shows a large blood clot on the right side of her brain, probably the size of a small tangerine, and what that's doing is pushing on the brain. She is just talking, but it's incoherent. She's moving her right arm to some degree. There's no movement on the left, and my worry is left alone, she'll go into a deeper coma, and it's unlikely to pull through from that.
Peggy collapsed while out shopping and was initially taken to Lewisham Hospital, where as a young woman she'd worked as a nurse. For husband Kevin and daughter Margaret, it's an anxious wait.
In my mind, I was really quite worried about whether she'd last the night. We were very worried and obviously very upset.
She is the centre of the family, isn't she?
She is. She's the heart of it. She's the heart of our family.
Yeah.
Cut down through the scalp.
The life-saving operation to remove the clot will take up to 2 hours. The bleed is on the right side of the brain, which controls the left side of the body. This is why it's Peggy's left arm and leg which have been paralysed.
Okay, draw, please. Pull this through the hole through.
The skull over this part of the brain is more than ½ a centimetre thick.
And this drill actually contains a clutch and gear mechanism, so when it gets to the solid bone, it cuts out.
Mr. Bassi needs to create a large enough opening to be able to remove the clot. After drilling through the skull, he must cut through the thick outer membrane, the dura mater, which also helps to protect the brain.
And there we can see the black is the blood coming out. What we can actually see here is the normal brain, or at least a small part of it, sort of a yellowy colour, and then the black is the blood clot itself. And the brain's bulging up under very high pressure. And what we'll do now is go into that and try and evacuate it. Suction up, please.
Peggy has a heart condition and has been on medication to thin her blood, which made the initial bleed worse. Eventually, the body's natural clotting mechanism kicked in, but not before the escaped blood had formed a large clot. An hour into the operation, and Mr. Bassi removes the last piece.
The brain, which initially was bulging out through our opening on the dura, has now settled down. And also, the brain actually is pulsating, which it wasn't doing as the pressure was high, which shows the blood's getting back into the brain, and one would hope that part of the brain would now have a chance of surviving.
The pulsating brain is a good sign, but it's too soon to say whether any nerve cells have suffered permanent damage. Two hours after the operation, Peggy is coming round on the high dependency unit. But the left side of her body remains paralysed. It will be several days before the doctors will know if she'll make a full recovery. Peggy had no choice about the damage to her brain. Sean does. His GP has advised him that, although a brain scan hasn't shown up any abnormality, he should consider giving up rugby. It leaves Sean with a dilemma.
One day I might get knocked out and I'll wake back up again. I know the consequences of that, and I know that being knocked out has affected my memory and has affected my speech slightly. I know all this, and I still play. I'm just conscious, if I stop playing rugby now at 27, I think when I'm 35, 40, if only I carried on playing rugby, what would happen? So I don't want to do the if only, so that's why I still play.
A fortnight after her operation, Peggy has made remarkable progress. As well as recovering her speech, she's regained much of the movement on her left side.
Lift both your arms up, Mum. Can you lift both your legs up?
I think I can.
Yeah, so you can move everything.
Yes.
It's a tribute to the resilience of the brain and the skill of the surgeons.
I feel well. I feel good. But I'm looking forward to the day when I'm going home.
Oh, we've got you back, Mum.
Yeah.
Got you back intact.
Yes.
It's wonderful.
It's been a fascinating journey looking at this most complex of organs. There's still a lot more to find out about the brain, but we've seen some of the ways that neuroscientists are doing just that. And it was a truly memorable experience having my brain scanned and looking at where my mind and personality reside. And when it comes to looking after our brain, a good night's sleep is essential, and so is keeping physically active. For Sean, the dilemma remains how to continue playing rugby while avoiding concussions. But there are techniques he can use to improve his recall. And keeping mentally active seems to be the key to maintaining your memory into old age.